Today we're going to make Cochineal lake. It's an aluminum hydroxide lake made with a bug juice dye, whose principal dye stuff is carbonic acid. The Cochineal bug was discovered by the Europeans in the year 1520, but they had a version of the shield insect this comes from called the Kermes bug that yielded much less dye. So you would find this dye stuff even in Viking textiles, but in very small amounts. This is what the Cochineal bug looks like. At least when they're dead. What you do is you put them in a little cloth sack. I use a baby sock. Tie it up and boil it. When used as a dye, this is what it looks like on wool. Da Vinci had one this color he got from a patron. He was very proud of it, and he was very famous about wearing it all the time because this was very, very expensive. About 16 years ago, I made some Cochineal lake. This is the normal color. I did not make these. Using a touch of alum and tartaric acid, and I got a slightly redder color. This is a pH sensitive dye. Now the problem is this reaction didn't react very well. It only made a little bit of paint considering the amount of chemicals I used, the amount of dye stuff I used. The pH threw the entire reaction off a little bit, so you can make it. It's just, I'm not going to give you as much as what you're looking for. Okay, so this is Cochineal dye. It's just bugs boiled until they turn pink or red. Alright, bug juice. This is alum, aluminum sulfate. People use this as a mordant while dyeing. It's not very expensive. You add that to the bug juice. Now, there's a reason I have this sitting in a bowl. This is washing soda, just common washing soda. If you buy it in a store, you want to be careful to get the pure stuff that doesn't have added brighteners or other cleaning additives added to it. If you have to, you can order it from a chemical warehouse to get chemically pure washing soda, but this is basically just a different form of soap. Now you add this to the bug juice alum, not the other way around, or your reaction won't react. I should have foamed up more. Didn't add enough. Put that on pause, we'll make some more. Alright, mixed up some more. Not enough. Should have done more. Okay, once you have your solution, pour it into a coffee filter, because you're going to get two products. This is a simple substitution reaction, and you will get an aluminum hydroxide lake, which chemically traps the dye, and the other byproduct is glauber's soot, which we will be washing off later. But right now it needs to be filtered out of the water. That was fun. We'll let this sit a while and then wash it out later. Here we have the result of our experiment. Zoom in on this. As you can see, we have a combination of pigment, which is an aluminum hydroxide gel, which is chemically trapped the dye stuff in it, and salt. This is glauber's salt. This is a simple substitution reaction. So you need to get rid of the salt to make the pigment usable. So what you do is you loosen it all up from the coffee filter. Pour it into a container. And you add some water to rinse the salt out. What will happen is your aluminum hydroxide gel or lake will sink to the bottom, the salt will go into solution, and then you can just pour it off like this. Do that a couple of times. And for the last time, you run it through another coffee filter to make sure you've got all the salt out, and to separate out the solids from the liquids. give you your dye, your pigment. You can do this with any dye. There are a couple that have special needs, like madder and indigo. I do those separately to show people how to do them. But for the most part, any plant stuff that is a dye stuff, 70% of them yield a yellow. So you can boil them up, pour off the yellow dye stuff, and do the exact same thing here and get a yellow pigment.